Okay, hello everybody. My name is Nicholas. I'm representing NUS Games Development Group to teach you all Unity for this orbital mission control. So before I begin, I'd like to thank Stanley and Harold for helping out with the presentation. And if you have any questions during the talk, feel free to approach them. So Stanley's at the back and Harold's in front. So the whole overview of this workshop is first we'll do an introduction to some ideas of game development. Second, we'll just jump straight into a project we have set up for you. Then we go for lunch. Then we continue the game development. And then lastly, we'll go through some miscellaneous stuff such as project setup and things like that. All right. So just a show of hands, how many of you are new to game development? I know so. How many have started on your game development project already? Okay. Do not worry. This talk is meant for you guys. We'll be going through a very basic introduction of Unity, and why do we use Unity? On the website it says that it's the world's leading real-time creation platform, and we believe that Unity is easy to pick up, well documented. There's multi-platform support, and it's free. And also, many awesome games have been made with Unity. So, are you guys aware of what these games are? So, like, Unity is notably known for 2D games, but on the bottom left, there's a 3D game in Unity, City Skylines. So, actually, Unity is very powerful. You can do many things with it. You just need to know how to use it. And that's what we're going to try to show you guys today. Just a small glimpse of what we can do with Unity. So, before we begin any game development project, we need to figure out what kind of game you want to make. So this usually happens at the very beginning. Before you even start, you think about things like what makes a game fun, what kind of knowledge you need to actually create the game, and if we have a foundation to build on, we will not be blindly jumping onto the development process. And as for this orbital, we only have 3 months, so we have to start small, keep it simple, and judge how much can be done within these 3 months. And knowing your own ability, please try not to go too broad or too complicated. And always remember to play test. But this one I'll go through at the end of the whole the workshop again, because after you get a better idea of what you can do with Unity, I think you'll make a better judgment on what you should make for Orbital. So game development, or rather a game in general, consists of a game loop. Usually there's a input, update, and render, and I'll go through the steps one by one. So at the very beginning of this iteration of a loop, you will check whether any input has been pressed. For example, in, let's say, Mega Man over there, if you press space, it will register as a jump. So we know in this frame that the jump key was pressed. So in the update portion of the loop, we'll check the game logic. For example, can the player jump? What do I mean by that? For example, is the player grounded? If the player is in mid-air, can he jump? That depends on your game logic. In some games, you can do a double jump, so you have to account for that as well. Other things is like, is the player injured or is the player dead? Then you also must check it over here. If yes, then we can translate the player appropriately and set the sprite to a jumping animation. For example, it could be set to the startup animation or startup sprite over here. And at the end of this loop, we draw the sprite in the new position in its new pose. And if this is done quick enough, we'll be able to see this animation play out in a very fast manner, and it will look like it's actually moving. So what does Unity bring for us? Well, there are a lot of things that have been extracted out. For example, the rendering portion is handled by Unity. All you need to do is to move the object in the scene, and the rendering portion of the game loop will be handled by Unity's rendering pipeline. In the update, we don't have to rely on just translation and calculating the gravity. We can just attach physics behavior to the game object and then add a force to the object. And also use Unity's animation system to play the jumping animation. We do not have to keep track of which frame we need to display, but rather we just need to know which animation we need to play. So using a game engine will help with the iteration of your game and make things a lot faster. So for today's game, by right we should have thought through and done paper prototyping, but for now we will just hand you guys a game idea, which is the Chrome Dino Runner, and we'll try to implement this in Unity. We'll talk more about the prototyping later, but right now we will focus on learning what Unity can do. So after spending some time dissecting the game, here are some of the gameplay features we need to develop. For example, if you look carefully in this GIF, we need to account for the dinosaur jumping. So this involves reading the user input and as well as applying a force to cause him to jump upwards. We also need to account for character animations. Notice how the dinosaur's eyes dilate when he hits the cactus. So it becomes bigger when he hits the cactus. So that's a different sprite that we need to render, and that is part of animation. We also need to account for collisions. How do we know if the game has ended? We only can figure out if he has intersected with one of the cactus in this plane. So we need to account for collisions to know when to end the game. We also have to move the dinosaur from left to right. So this can be done in many ways, but we will explain our version later on in the talk. And lastly, we also need to show posting of the UI and the high score. When the dinosaur dies or say gets hurt, there's a game over sign with a restart as well as a high score usually at the top of it. That involves some sort of user interface elements in the game, and Unity offers such support as well. So based on these key gameplay features that we have defined, we need to develop some game components that communicate and help drive the system. So the player controller will be in charge of the player movement. The obstacles will be in charge of the movement and the collision. The obstacle spawner will be spawning the obstacles, and the game manager will keep track of the overall state of the game. This may not be very clear to all of you, but just keep in mind these 4 key components, and we'll be going through them step by step with you all. So have you guys downloaded the project already? So the idea of this workshop is that we will be running through a few versions of the game from very basic, and then we start slowly adding features. And halfway through the talk, we will be asking most of you to work on an exercise with the knowledge you have gained. So I do hope that most of you will be following along and coding with me. So if you set up the project correctly, and you should see this screen, but let me switch to my Unity engine view. All right, and I hope you don't mind I sit down. Okay, if you look at this screen, there are quite a lot of things going on, but let me just explain to you what most of the things are. On the top left-hand corner, there's this window called the hierarchy. It will show you all the things that are in your game, the game objects in your game. For example, we have the camera right here, and we have some background, and these objects can be moved around in the scene, and this can be viewed in your scene window. So in order to move things around, we can click on these widgets at the top, and this panning tool lets us drag things around. So another important window is the game window. This is actually what's going to be presented in your final game. This is like a view of the game rendered by your camera, which is here. So if I move the camera, say, to the right, notice how the camera preview changes and the game view also changes. On the right-hand side, there's this inspector, which gives you more detailed information about the game objects in your scene. So as you can see here, I've selected the main camera, and I will get more information. For example, this transform. This is very important. All game objects have a transform. It determines their world position in the scene. So the camera currently is positioned at 0, 0, 0x, 0y, and negative 10z. It also determines your rotation and the scale of your game object. So to illustrate, when you look at the ground, if I were to increase the x value, so if I click here and drag, I will cause the x component of the ground to scale. So feel free to try this out on your own project and see what the other things do, like rotation and various scales. For the rotation, hang on. Okay, let me just reset this.
For the rotation, I think it doesn't affect because you're using a
Yeah,
sprite
it's a sprite. Yeah.
Yeah, so the sprite renderer always face the camera. So actually, I think you can try a Z.
Yeah, the Z would work.
Yeah.
And notice how it's rotating around the origin. The reason is because the sprite is actually a square, but you don't see the top portion of the sprite. But that's just a not so important right now. But yeah, just feel free to play. And if you're not sure why these things are happening, feel free to approach Harold or Stanley. Stanley, who's behind. Okay. So at the very beginning, let's work on creating a player. So to create a game object in your scene, I apologize, I haven't talked about the project window here, but that's a good segue anyway. So in order, the project window on the bottom will show you all the various assets that you have for your game. So it comprises of things like your scene. So scene is like you could think of it as a game. Yeah, that'll be good for now. And then there's also things like scripts, like C# scripts. We'll get into that later. And we can also have things like animations, sprites, and audio files. So pretty much anything you can put here. It's like a representation of your file system. So in order to create a game object in your scene, you can go to the hierarchy, right-click, create empty. This creates an empty game object. So the empty game object will have a transform to determine its world, position, rotation, and scale. We can also rename this game object by doing a left click on it, and it will highlight the name, and we can update it here. Alternatively, we can update it in the inspector. So just to let you know, there are multiple ways to do it. And so if we follow the slides, we can start attaching some components. So the very first thing we need for our player is to actually view it. So the player in the original Chrome Dino game is a dinosaur. So our dinosaur is a sprite. We can find it over here in this asset window. Over here. In order to render the sprite on the scene, we need a sprite renderer. So we can attach components onto our game object by clicking on the inspector's Add Component button. And from there, we can do a quick search for a sprite renderer. So it can, just to let you guys know, it also can minimize and maximize. But the important part is here, we need to attach a sprite into the sprite renderer for it to display. So we can just head to one of the assets here, click on the sprites folder, and there'll be this sprite sheet that we have created, and we can drag this dino into the sprite here. Okay, anyone having issues with this so far? For example, you don't see the dinosaur even though you attach the sprite. Okay. Okay, let's continue. So other things about the player. The player is subject to physics behavior. For example, he is subject to gravity. He's subject to collisions. So in order, just to remember this, we just have to add two components, a rigid body and a box collider. So in the component compartment here, we can add a rigid body 2D because this is a 2D game, and a box collider 2D. So you can read the documentation, but a quick overhead idea is that rigid body introduces some physics behavior, and the box collider 2D determines the bounding box where collisions are triggered or detected. So one quick note is that sometimes your collider, which is this green, okay, let me pull it out. This green box here may not enclose your sprite very well. What you can do is click the edit collider. If you see my mouse here, edit collider. And then you can start dragging this around. So maybe like, oh, I don't want his outer portion to be counted as part of his body, then I can make it smaller. In some cases, you may want to do that. This is to make the game feel better for the player. This is after some play testing, of course, but just a quick pointer to note. Okay. So if we have this setup, what happens if we click play here? We'll actually start the game, and oh, a dinosaur disappeared. So the reason why the dinosaur disappeared is because his order in the layer is not correct. So general idea is that the sprites are layered. In order to know what to draw in front of each other, there's an ordering in the sprites, and we need to update this ordering in order for it to be shown on the screen. So if I put it to the side here, we can change the order in the sprite renderer to say maybe, oh no. Oh, I think I know why though. Yeah, it's the wrong side. Yeah, this is weird. Hang on, huh? Why is it not rendering?
Try negative.
Yeah, it doesn't work.
Check what's the background set value.
We can just do this. It should still be rendered though. Give me a moment. Feel free to figure this out as well.
Oh, wait, no, your transform is a negative 17.
Yeah, that's right. Okay. Okay, we solved the problem. It's the Z position. So basically it's the same thing. It's the ordering in the layer, but there are two ways you can do it. You can do it in the sprite render, and you also have to account for the Z value here. So if you think about it this way, there's a X value, there's a Y value, and there's a Z value, right?
Yeah, Z value goes.
Oh yeah, sorry, a Z value that goes into the screen. It does.
No.
When the Z value goes out, it comes out.
Yeah.
So if you have a negative value.
I think Z value goes into the screen. Unity uses a left-hand
Oh, yeah, that's right.
so the camera is at position at -10, so you put it behind the camera, you cannot see the player.
Oh yes, my bad. So if you increase the Z value, it'll be forced into the screen. That's why it'll be rendered behind the background. So we have to force it in the negative Z direction, which is into the player's out of the screen. And then we can get something like this. Okay, so problem is solved, and he's now subject to physics, and he stops on the ground. So one thing I'd like to point out is that the ground actually has a collider in order for this to work. So this we have already set it up for you guys. So if we do disable the box collider, oh, okay, yep, the dinosaur falls to his doom.
Oh yeah, in practice, generally for 2D games, it's a common practice to put a collider or some guard on the screen boundaries to prevent anything from leaving the screen. So we will explain more on that on the spawning of the character.
Yep. All right. So we have set up this little dinosaur, and now we need to be able to handle some sort of input and cause him to jump. So in order to first read input and then have some sort of behavior, we need to write a script for it. So what we can do is create a script here. So personally, I like to compartmentalize my project like so, where I create a folder called scripts, where I put most of my scripts in. And then in order to create a script, you can do right click, create C# script. And before you press anything, I advise you to update the naming here so that the class name will be correct in the editor. So what I would suggest you guys to call it is something like player controller. This controls the player, so it's a player controller. If you double click it, it should open your preferred IDE. Normally it's Visual Studio. I've set it up to Visual Studio Code here, but it's still the same thing for the most part. All right, so are you guys familiar with, let's say, you guys know Java or at the very least some programming language, right? So I don't need to go through like some OP concepts or just about classes, right? For those who are not sure, just feel free to approach Harold or Stanley. But so if we follow the slides, we can see that we need to have first we need to do player input. So this player input needs to be called every frame, and this is done in update. So there are two important methods within this script. There's start and update. Start is called at the start of the game, and update is called for every frame. So if you do recall what I was talking about at the start of the talk, where there's a game loop, this update will happen before the rendering, and in Unity you would do your input here as well. So if how I normally think about this is, what's the key that what's the input, and then what is the expected behavior. So let me write some code and maybe you guys can figure out first. So say if input dot get axis is jump equals to 1, so what this line says is if the input key is pressed down, then we need to do the jumping behavior. So in order to cause the player to jump, we need to be able to access the rigid body of the player, which I have attached here. So if you saw this, we need to be able to have a reference to this rigid body, apply the appropriate physics behavior, and then when it will be applied in game. So we need a reference to, again, the rigid body here. Notice how the name is the same, rigid body 2D and rigid body 2D. And then I call it, say, RB. Now, this, as we all know, this is not instantiated. So what we have to do at the start of the game is to set it to something. And normally how we get a reference to this component is like so, get component. Sorry. So to put it in simple terms, find the component in this game object that is a rigid body 2D and set it to our private variable here. So the idea is I would attach this script. Oh, my bad. I'll attach this script here, like so. And so this instance of the player controller will search this game object for this rigid body 2D and at the start of the game. And so now for the rest of the game, we have a reference to this rigid body. So far, okay? All right. And then, yep.
Game object and game component hierarchy unity at the object tree.
Oh, it's okay. All right, then, so now we have a reference to the rigid body. Now when we press jump, we can do a few things. For example, we can add a force to cause him to fly up. We also can set its velocity in the upward direction, or we can also translate it. We can do many things, but for this workshop, we'll just set its velocity in the upward direction. Oh, no, no. So the rigid body's velocity, which is referring to this velocity here, you can see, we set it to a vector. So, okay, never mind, we do this one. So we set it to an upward vector. So in the game, the up direction will be the y-axis, right? So the x component of the vector should be 0, and the y component should be some variable that you set. So for now, we'll set it to, let's say, 5. And this should cause the velocity of the dinosaur to move upwards. So let's see this now pan out in our game. But we have to wait for it to compile first. Oh, never mind. So I press space, which is supposed to be attached to the jump, and look, he's jumping. But there's a very, very big problem in the code here. So sure, we can say if I press space and he jumps and it's fine, right? But what if I press space multiple times? Then he can fly forever and then leave the game and win. Yeah, so we also need to account for many other things than just player input. We have to account for the game state as well, right? So if we think about it logically, how do we know if the dinosaur can jump? The dinosaur can jump only if it's grounded, right? So we have to account for that in our code. This is not done for you by Unity. So if we follow the slides here, I've done a trick. It's not a trick, but it's just a hard-coded value. So I just take this, the current y value. So if I'll just take this current y value and then I'll check whether he's past this value. If he's past this value, I assume it's not grounded.
I think you can check the collision.
Yeah, I know, but we won't go through collision. So in order to know what's the game object's position, we first need to get his transform, right? Because the transform is his component. In this case, we do not need to use this get component method. We can just directly call a transform dot, and then we get his position, and we get his y value. If the y value is below, say, this number, then we will allow the jump. But okay, let me adjust it a bit. Say like this. By right, there are better ways to do this, but for now, going as it goes along, this is what I'll teach for now. There are better ways to do it once we learn about collisions. So now, when he's grounded, he can jump, but no matter how many times I try to shoot him upwards, when he's in the air, he does not jump. So this is the expected behavior that we want, right? Okay, another important part of Unity that I'd like to share with you is exposing variables to the inspector. So as we saw just now, the jump value is not very good, right? So we have to manually edit it, say 12, and then we go back, wait for it to compile, then we run, and we see, oh, it's too much now. Then we have to stop, go back, update this. This is really slow. So one thing we could do is expose this variable in the inspector, and it allows us to tweak it and not have to edit the code. So what we can do is create a public variable, and for our purposes, we'll call it, say, jump velocity. Since this is a public variable and it's a float and it's serializable, you'll be able to see it in the inspector. And then we can just set it here. And once it compiles, now when we look back at the player, there's this jump velocity option here. So if we run play, if I press space, it's not moving because it's using the 0 jump velocity. If I were to increase it like this, and I click the game, then he starts jumping small, and I increase it even more, you jump upwards. So this exposing this variable is very useful for iteration because we can manually tweak the values, and then we can see visually whether it's up to our liking. And this is also very important for your designers. But do take note, if you were to change it here while the game is running and you stop running the game, it'll be reset. So just try to remember this value and put it back in. Don't stop the game. Okay, so actually this is what we need for the player for now. Now we need to add obstacles for the player to run into. So this brings me to our slides. Oh, where's that slide? Okay. So there are many ways we can do movement in the game. One way is to, since this is an endless runner, one way is to have the dinosaur keep moving right and have the camera follow him so that the dinosaur is always at the bottom left or the left side of the screen. However, there are many limitations to this. One of the biggest limitation is there's a limited representation of the world size, and like once you pass a certain limit, you just cannot, right? So let's flip it around. Let's move the cactus towards the dinosaur to simulate movement. This way, we get the effect we want, which is visually the dinosaur is moving, but our camera doesn't move, our player doesn't move in the X direction, and this will be much simpler to handle. So this brings me to our exercise. I hope you guys can create a cactus obstacle in the game, and these are the requirements. First, the cactus must move to the left at a constant speed, similar to how the dinosaur moves up with the velocity. It should not be subject to gravity, so think about where to look for to change this value. It should have a box collider to detect collisions, and we'll need this later. And you can use our cactus sprite, or you can find a cactus sprite online. Yep, and you guys have 10 minutes. If you need more time, we'll think about it. You need help?
Yeah, you need help.
Are you guys working on the exercise? No?
Oh wait, oh, this. The important thing is like you see this and this, and then like you have like less than half screen space for those. Oh, it's like some people like it's like scene is here, spectacular is here, like the rest is like visible. That's just genius. What's this? Oh, wait, what's that? I think it was left in as a keeper. No,
Yeah, surprised that your jump key is not working. Will you check? Oh, that's good.
What? Jesus. What is this like? No, I didn't see that. This is
Oh, do you attach the script? Oh, you didn't.
serialized view.
Sorry, seriously.
Things appear and the inspector.
Copy of the
No, something will appear. For example, the customer right? And that's the whole limit. And I think he's more qualified to talk more. So he's just creating your own custom inspector for custom constantly serialized and all of the fields. First, the velocity is a member class. And a member, it's a property of a rigid body. Because any rigid body responds to physics. So first you have to access the rigid body. Wait. Are we using a rigid body for this? Okay. Yeah, I was thinking right. Are we using rigid bodies?
Huh?
Are we using rigid body or transform?
Rigid body.
Rigid body.
Sorry.
You can just mod. Yeah, just add a rigid body to the thing. Not translation, just in case something happens.
You check your unit here. This character's name is called. Because I know this thing is called.
Your characters, your transform is like because you right click every time it's like that. The problem is always like that. Why is it not moving? Do you attach a script?
What do you set up?
Let me do it. Where's your video? No.
Yeah, just to make things a bit easier.
After that, it collects the ground, and fiction takes over and applies. Or you just make a material that's frictionless instead of like bothering you. Then just expand the box. Yeah. If the box rotation. Okay. What do you need help with?
So if you all want to create a prefab after you're done adding all your stuff like your rigid body and everything, just drag it into your assets window, and then now you have a prefab. Then you can use this. You can use this prefab when you're in your script. So
It's thinking of so much. What? Okay.
You haven't created any script.
do you remember what?
Then you push the key out of the way, right?
Yeah.
It's calling you.
I'll just go through it. So if you all remember, the player has a collider and also a rigid body. So the rigid body is for physics. Because you don't want the characters is subjected to gravity, you have to change from dynamic to kinematic. It's a physics thing. So dynamic is subjected to forces, kinematic is just subjected to change in position. So if you think in terms of physics, position inside the zeroth term, your velocity is like your change of position, and your force is like change of velocity. So, and the other thing you need to add is the box collider. Remember to resize your characters box collider, so it will be tight. Now when you are done, you can just drag this into your window, and now you have a cactus prefab. Then you can use this cactus prefab to spawn a cactus in your script. I taught them to make a prefab.
Oh, okay. Thank you.
So for this house,
Why are they 1,056?
for this house,
I think I'll give you guys a bit more time, like 5 more minutes, if that's okay. Or are you guys mostly done? No? Okay, okay. Around 5 more minutes. Oh, and for those who are kind of done, you can always go to this link to ask questions anonymously if you, or is it anonymous? I'm not sure. But you can ask questions through the slides, Google Slides.
It's a component.
So everything will be called rigid body.
No, it's a component which is selected. So yeah, a rigid body can change so this rigid body is selected to things. So
Okay, so just set time. So but it's a class so yes, you can set your own like 5 seconds off. If it's not rendering on the screen, but you just destroy it.
the idea is
Camera. With camera cannot see cactus destroy.
Okay, guys, I'll restart this whole thing.
Behind the dinosaur and camera not rendering.
Okay, so one thing I realized that maybe I wasn't very clear was that once you create the script, you need to attach the script onto the game object. So I think one common question was like, how come it wasn't moving? But the reason was you actually need to attach the C# script onto the game object for it to actually jump. So that's one thing. Another thing was the exercise was, what I wanted was for you guys to create a script to attach to this cactus, and then once that's done, it will exhibit the behaviors shown here in the. It will exhibit these behaviors. So I wanted you guys to create a new script, but not to worry. I'll run through it right now. So it's like a quick recap, but to create a script, right click, create C# script, I call the script cactus obstacle for I don't know what reason, but that's why I call it in the slides. So, and then if I update this, we can see that what we want to do is very similar to the player controller, but it's just that the cactus obstacle will be moving to the left for the whole game. So what we can do is actually create a speed, say 10, and at the start we get a rigid body. Okay, let me write it out first before I explain to you what's going on. But nope. Okay, so the idea is that we have a cactus. We give it physics behaviors through adding rigid bodies. Then at the start of the game, when we spawn this cactus, we just get the rigid body through this method called via get component, and then we update the rigid body's velocity to move to the left at the speed that we desire, which is in this example 10. So it's very much the same as the player controller. It's just that we don't read user input. We just have it move forever. And then when we go back to the Unity editor, we can get our cactus. Oh, it's a prefix. Okay, and then we add our script onto it, and it should exhibit the behaviors we want. One thing to note is we also have rigid body, we have box collider, and we set the gravity scale. This is kinematic. Okay, there are many ways to remove gravity from the physics behavior. If you set your body type to dynamic, we can set his gravity scale to 0. Alternatively, we could change his body type to kinematic. So I believe I put a link, or you could search the Unity documentations on what these body types are. But if we also can have a quick preview of what it does by just running the game. And we get the desired behavior, which is the cactus moving from left to right, but it's not on the screen because of the Z position. Just have to update it here. So just to recap, at the start of the game, we set the velocity to the left, and then it just keeps moving forever and ever. Yeah, right now it's a feature, but we'll work on resolving that later. Another very important thing to note is that the cactus has the box collider so that we can detect collisions, which is the next thing that we're going to implement. So to know when the game ends, we need to know when the dinosaur collides with the cactus. And since we have already set up the colliders for the dinosaur and the cactus, we are now able to detect this. For our design, for this workshop, we decided to detect this in the player controller. There are many ways you could go about this, but for simplicity, we did this in this manner. So if you notice the script, this is a mono behavior script. There's a function that we could override, which is on collision, enter 2D. Did I spell it wrongly? No. Yep. So, so what it does is whenever two colliders with rigid bodies intersect, the player controllers on collision enter 2D will be called with the opposite collider. So the idea is that when the cactus intersects with me, the player, this function will be called, or this method will be called with the collider of the other object. So to detect this, what we could do is do a simple printout into the console to make sure that this thing works first before we add additional behaviors. One way we could do this is this thing called debug.log, or we could use print also. And we can print out like a string like ouch. So recap again, when the cactus hits me, this method is called, then I print to the console ouch. So let's test this in our game. Okay. So okay, wait. Sorry, I forgot to tell you that you can click on the console here. If you do not see it, you can go to Window, then General, and then you click Console, and then you should see like this this console over here, which debug.log writes to, and you see, oh, ouch, ouch. So there are things that we do not like about this. One is when he hits the ground, he says ouch, which is not supposed to be the case, right? Because the ground is not a cactus. Another thing is that the cactus pushes the player infinitely, but that one is okay because we will end the game anyway, and we will care about it later. But the first thing that I like to point out is that basically when the player hits any collider, and that includes the ground, that method is called. So we have to do a simple check for this. So what we could do is over here, so if we can somehow decipher which collision 2D this belongs to, then we can decide whether we want to print out or not. So you could actually get some information, additional information about the object. For example, we could get his name. So the cactus here is named cactus, and the ground is named what's it? 01 underscore ground. That's the name of this game object. So a simple fix for this is we get the other collision to this, and we get his game object, which is the game object that I was referring to just now. And then I get the game object's name. And we check whether it's equal to cactus. And then if it's a cactus, then we print it out. So let's always just test. When you're new to something, just keep testing and verify whether it's correct. So look, he hits, and now there's only one ouch. So that's the cactus's collision that we have detected. All right. So now we have that done. We can move on to our part 2 of our so-called part 2. The idea is that those who haven't jumped on yet and who wants to jump on, seeing how hands-on this is, you can actually go to the versions over here under the project, and there's a version 2. And if we open that scene, it's actually where we are right now. So if you want to jump on right now, you can go ahead and load the version 2 and quickly jump on. Which one? Oh, what? Okay, never mind. So if we continue working on our scene, let's do a quick recap. We have the player, we have the cactus moves in the player, and we detect the collision. So what I have planned to do now is actually decide how to spawn this cactus. So the idea is that if you want to simulate a dinosaur moving through a desert and the cactus is appearing at certain intervals, what we could do is actually spawn this same cactus at the same position at set intervals, so that it will look as though it is crossing the desert with cactus placed evenly, right? So what we could do is create another game object that is in charge of spawning these cactus at set intervals, and then we can have multiple cactus spawn basically. So that's what I'm going to do right now. I'm going to create a spawner for these cactus. The same thing applies. Create a game object. I call it a spawner. I set the spawner to say somewhere here for now. And I create a C# script here called a cactus spawner. Oh yeah, one tip that I do have is that for things that don't really have any visual presence in the game, it's always good to attach, say, a sprite to it, so that we do not have to like find it when your hierarchy gets very messy. So sometimes I like to give it a sprite so that I can easily find it without having to search through to the words here. So let's see if we can find a good sprite. Okay, I'll just put this first. So this is our spawner, and we can easily click on it now, knowing where it is in the scene. And notice how it's not in the game because it's outside of our camera. If we move it a bit, if we move the camera a bit, then we can see it if it's set correctly like this. But yep, we just place it outside for now. And we also remember to attach the cactus spawner script here before we begin. So if you double click, it's the same thing as before, a mono behavior, but now it's a cactus spawner, which is in charge of spawning cactus at set intervals. So one thing we could do is in the update loop, we check at, let's say the time is, right now what's the time, and then if the time interval of 5 seconds has passed, then we spawn this object. Or we could also do something called coroutines, which is a neat thing that Unity offers us. It's easier if I just write it out first, then I explain. So first we create this this function that returns an I enumerator. I'll explain that later, but just let me type this out first. And then okay, so wait, okay, I think I just write this as well, just to give a good idea. Okay, so for the I enumerator, you could think of it as an iterator, but so basically it will iterate through this this code block, and when every time it sees a yield, it will stop its execution. That's a very hand-wavy way of explaining, but I think that will suffice for now. But the idea is that when we return an I enumerator to this start coroutine, the Unity would execute this code until it sees this yield statement, and then it will wait for how long you want it to. So for example, when I start the game here, I start this coroutine, and it will execute whatever the code here. Let's say I execute my logic, and then in that frame, and then it will stop here and wait for 5 seconds. So 5 seconds later, then I'll hit the end of this while loop and repeat. Did that make sense so far? Okay, maybe if I write some more stuff. So the idea is that every 5 seconds, I want to instantiate the cactus. So there's this method that we can call to instantiate a cactus that we have not defined yet. This will actually spawn the game object in the scene. And then I hope this makes it even more clear. So we instantiate the cactus, wait for 5 seconds, then we instantiate another cactus, wait for 5 seconds, instantiate another cactus. Now, what is this cactus then? We can instantiate these game objects in the scene, like, for example, this cactus game object. And we can, and we call instantiate, it'll make a copy of that game object. And then if you think about it, what happens when we copy it? We copy it and then it will move left immediately because it's spawned, right? Because of the start in the cactus obstacle here. Okay, if that's not clear, let me just write it out first. All right. So we have a reference to the cactus that we can set in the inspector, and we spawn it at every 5 seconds. So let's see how this pans out in the editor. So in the spawner, we have a public reference to this cactus that we have not set. So right now, if we were to run, we'll get like a null pointer. Over here, you see the variable cactus of cactus spawner has not been assigned. So we can actually assign this cactus into that that portion, right? So there's another tip I like to share. Notice how I want to drag this cactus in here, right? But sometimes it can get a bit finicky. For example, if I want this to drag this in and I click the cactus here and then I can't drag it in. So what you could do, there's this little lock, if you can see my cursor. Okay, my cursor is here, follow the lock here. And then when I click anything, it will lock the details here. And I can drag the cactus in and I can unlock it. And then if I run the code again, okay, it's not very obvious, but how do I do this? Okay, we'll wait for 5 seconds. But if you notice, 2 cacti are spawned, if that's the clue, yeah. So 5 seconds later, another one will spawn at that position, and it's spawning here again. And then like they're like spawning in the same position, which is not desirable. We need it to spawn at the spawner's location. So if we look through the documentation, we can see that we can actually assign the position of where we want to instantiate it by setting a position. In this case, we want to spawn it at the spawner's location and not at the current cactus location. So we take the spawner's transform and we take his position, and we need to set the rotation as being spawned at, which is a quaternion dot. Okay, so we spawn the cactus at the spawner's position with identity quaternion. Quaternions, as a hand wavy explanation, is just a 3D rotation. It's just a representation of a 3D rotation, and the identity means that there's no rotation. So the cactus will be spawned at the correct orientation, in the upright orientation, or with no rotation. It's the same thing. So if we repeat this now, we see that our cactus is spawning. Oh, but what happened? Oh, I know why. But okay, why is that about? Oh, okay. If you notice something is going wrong with the game, Like if you see how, oh, it's fine now. Okay. False alarm, guys, but it's okay. So right now we have what we want. It's spawning a cactus and it's falling away. And yep, it's spawning at this guy. And if we move the spawner around like this, oh, we are actually changing the transform. Yeah, so if you see this parallel, you actually can implement like a gun like this. It's the same thing. You're spawning something and it moves in that direction. If I want it to rotate, then we have to update how it's being rotated. For example, if like the guy shooting in a different direction, we need to update how we are spawning the cactus. So yep. So far, are there any questions? Okay. Okay. Now one thing that we could do with our cactus is that we notice that there's a cactus in the scene, but we don't really want it. What we could do is actually create a copy of this as a prefab. So the idea is that a prefab acts as a template of a game object that can be reused in your scenes. In order to do this, we can drag it into the project window. And I normally create a folder for this. It's called prefabs. I take the cactus, I drag it in here. Oh, there's already another prefab. Okay, let me, we can ignore that. I'll create the prefab here. And now we have a cactus prefab with all the components that we want. So we can just drag it in like that. And it will all have cactus obstacle script, box collider, all the things that you want from a cactus. And with that being said, now we can delete all instances of the cactus. And in our spawner, we can drag the prefab instead inside. And now it will spawn the cactus appropriately. Okay, I'd like to point out a bug that we have so far. So if notice how when the next cactus comes, we are not logging out that we got hit by a cactus. If you notice, we did not get the ouch. So if we look carefully, the cactus that are spawned are named cactus clone. So this is not very, this is not the same as what we are checking for in our player script. In our player script, oh yeah, we're also not even logging it, but our player script is checking for cactus, right? What we could do is do like cactus clone, but this is not really advisable. Yeah, what if we clone this clone? Then how? Then infinite cloning. But so what we could do instead is we could use tags to group all the cactus together. So a tag is something that we can apply to multiple game objects, and the game object would share the same tag. So the idea is that a cactus would have a cactus tag, and any cactus that is spawned would also have a cactus tag, which we would be able to check in this script. So let's begin by creating a tag here. So, oh, my bad. Let me fix the compiler first. Okay. If I click the okay, in the inspector, you can see that there's this option called tag, and currently the cactus prefab is not tagged at all. It's untagged. So what we could do is we could use one of these. We have already created one tag, but just for completion, I'll show you how to create one. If I click add tag here, we will create a new tag here. and let's say orbital, right? For fun. So we created a tag called orbital. And now when we go back to the cactus, we can set it to orbital. And then in our player script, we can just check for this like that and log out. And if we try our game again, it should say ouch now because we hit the game object with the tag orbital. And also notice when I make a change to the prefab, it applies to all of the game it applies to all instances of that prefab. So if I click this version, it's orbital. If I click the next cactus that's coming out, it's also the same tag. So this is creating prefab is very good because you just have to change it once and it will apply to all the prefabs in any scene. Okay, now we have a quick exercise again. So knowing how collision works now, and we notice, as I mentioned just now, that the cactus goes on for infinity. Imagine if the player is super skilled, right? Like he's very good at games, so he just keeps pressing space and he dodges all the cactus. What happens then is that we pile up multiple cacti, right? And if it piles up more and more, we need that the game needs to account for more game objects, and this causes the game to slow down. And eventually, when we reach a critical mass, the game cannot be played anymore. So, optimization we should do is to despawn cacti that are no longer a part of the game. So let's create a despawner that destroys the cacti appropriately. And so basically the idea is when the cactus is out of the screen, it should collide with this despawner and it should be destroyed. Okay, so I'd like you guys to spend about around 15 minutes and play around and see if you guys can implement this despawner.
Why make a despawner when you can create a projector?
And then what happens?
Set lifetime.
Oh, we want to do an exercise. Yep.
One of the objects. I think the issue in here that the script is somehow destroyed. Somehow all the text forms. Wait, what is mean?
If you got any issue with like installing directives or like can't even run, can't even compile. That's the problem. How do you set it up? Or you just download and it works? Right, okay. Yeah. Sorry? Oh, I'm talking about Unity in general, not the project.
This is Unity for Mac. Don't know the Unity for Windows, right?
Yeah. You know how to set what's the height to set for the small?
Yes, Chinese capacity thing.
Oh, you can set it.
So you set slightly of
Yeah. Visually, visually it's fun. That's the whole point of that smaller guy.
Oh no. Oh, what is this naming convention? Oh, it was just...
I can't change this thing.
Fix it like that.
It's like when I click this, it's in this. Oh, okay.
Yeah, exactly. What is wrong? I'm interested.
Some codes.
Oh, okay.
So this is not
What do you say first?
I think it's easier to use.
but I think I see open.
Oh, no, you shouldn't have.
This one is the one.
You see?
I think so, but still they try to do it.
Yes. Okay, pause. You see it registers, right?
Okay.
So something was. Okay, I think before is the checkers, right?
Because just now they try to add this one. I can't find one. The one that it's supposed to be just the spot. Or is it because it's not
You see?
Okay.
Yeah.
Oh, player? Yeah, your player? Oh, Jesus. I actually doing this music stage 7K, right? Because X moves you die. Oh, if your X moves you die. It's just a very easy. Okay. Oh wait, no, you can't. Yeah, you can't.
you're just
You are two learners. If you X moves, right, you are dead. If your only movement is enough, your X will not move. It would it's not say colliding with the movement. You're colliding like normally.
Then I just need to check
If you want to save a smaller, you can drink anything. As long as it's a game option.
can drink into the beer.
Whatever you want.
You don't need another object. You can just change your characters.
I'm supposed to see this here.
Yeah,
Oh, it's nice.
No, it's not related. Oh, yeah, it's behind that, yeah. That's why you want to shift it around.
Oh, shit.
So you press this move thing. You want to go check the responder? I will still go through. So now this destroyed. Well, you just think about it, technology, like count 1, 2, and then it's fine. Okay, there are ways to go about this. Definitely it's not this. So, my quick random evaluation will focus on 100. So
I'm not sure if they changed that. So you put your game
there are ways to go about it. You can look into the layers. Oh yeah. So yeah, it's getting started. Definitely there's another way. So what there is in the system is something like this. I'm not sure. Usually I can explain this fully, but the idea is no, this is the sprite. So this is just how it's rendered. So you have to create your own layers, and then in the settings at the top left, you can decide who in which layer interact with each other. So for example, there can be the player layer ground and the ground is ground layer.
It's not a comprehensive.
But yeah, it's also triggers. You could set the
Game has trigger
and then you have to change how you have to set collision. Instead of collision, you do on trigger. Yeah, on the trigger, you set something
My partner is
I also think that
it's like I think okay, I think I mean I asked
Does it take so long?
yeah, it is, does it disappear? Where's your collider? Where's your collider? So this corner is my. Oh, wow, you do that? Okay. Different. I mean, the collider is just the issue.
Oh, so you touch the corner.
Oh, yeah.
It was just correct to touch anything. It was just correct to touch anything. Because
Sorry?
my use color, I thought that you'd be like overlay each other, then I destroy it.
Yeah.
They just touch you.
Collider can be overlaid as well. If you set it to trigger collider.
Oh,
Collider, it does.
Or you just ignore collections.
You can do that one.
But let me see
What the
This what? Invisible or something on the color.
Oh yeah,
Yeah.
not render.
Why?
Oh wait. I'll go back there.
Lock rotation. Lock rotation.
Maybe I have to tell
On review
I think someone's asking this question. Oh, what happens to the background? Oh my god.
oh my goodness.
it's like it starts off like
Oh, I did not. Okay, so the idea, it's in your rigid body. If you look in so under constraints, you have to lock it's a Z rotation. Yeah, I did not go to that. Very sorry. I will update you that. And what is your sky time? That is about
supposed to
that.
be fancy.
Yeah. By right for now.
But this thing
Oh, I suspect you attached a beam objective or you set.
this is
People that like
Or you added some stuff like the air control.
okay.
You can use
Oh,
but I think it yeah, unpause again before you so so thanks for everything.
Sorry, what's the line?
Yeah.
This was this line.
Okay, so look at the code for the player control when he gets hit by scatter. So do the same thing for the respawner. But I need to check this with the thing. So I'll go to it. Okay, guys, so let's continue. And after this, we'll go for our lunch break. Let me explain how we can do this. There are many ways that we can actually despawn the object. I saw a lot of you creating a despawner game object, and then some of you have this found this method called on become invisible, and that special method will trigger when the character leaves the screen, which is quite cool. I'm just going to show you one of the possible ways. So, okay, let me just write the code. So, what I do for this is I don't create a new script. I just create a new cactus. I update the cactus obstacle script, and I also create a despawner that lives in the scene. So, just to illustrate, I create an empty game object called the despawner, and the naming has to be quite specific because that will affect how I'm detecting it. I give it a rigid body, and I give it a box collider 2D. And so over here, I increase the bounds like so that anytime a cactus appears, it will hit the despawner, and then it will trigger the collision, right? Another important thing to note is when I run, if you observe, it's subject to gravity, which is it's useless now because it flew away. One thing you could do is just change the gravity scale. For me, I set the body type to kinematic, and it should still work. So you click the despawner. It should still stay still. And now I check whether, as the cactus, I check whether I intersect with this despawner. If I do, then I destroy myself. And that's how I do it. There are many other ways you can do it. Let's just update this. So same thing. In fact, we could just copy some parts like this. And then instead of the tag, we check for the name. And then it's specifically despawner. Definitely there are better ways to do this, but for now, this will do. And now the thing that I did not explain to all of you was what is destroy. So if we look at the documentation, destroy will take in some arguments, and in the simplest form, it will take in a game object. And I can do, let's say, I can destroy the game object like that. So I'm destroying me, the cactus. So the cactus obstacle is attached to the cactus game object, and I can just destroy myself. Very common mistake for a lot of people is they do destroy this. Okay, what happens here is you're destroying the cactus obstacle component, but you're not destroying the game object. So okay, to illustrate, let's do the proper one first. Okay, and I hope it works. Okay, so let's observe the left-hand side. Oh, it doesn't work. Okay, let's debug and check out why. So during these cases, right, what I like to do is always check print out the console like this. Maybe like another cactus, okay. And then, yeah, I could also print out what I'm hitting, but yeah, most likely it's... Oh, it's colliding, no? Okay, let me get rid of this dinosaur first. Simple way is put him here. Oh, it's not colliding. See? So okay, let's. So I heard someone suggesting maybe it's the Z value, so we just test it out here. No, it's not. And let's see how the cactus is set up. It's kinematic and the despawner is kinematic. Okay. So it's also using full kinematic context, but the cactus is not. Okay, so I believe the problem is this. When two kinematic objects intersect, they will not trigger any trigger those properties. They will not call the collision enter. So what I could try is enable useful kinematic context. When if you look here, if you take it, it means that kinematic collision should be allowed. So kinematic cactus with a kinematic despawner should be allowed. So let's test if it's correct. See, and because I've enabled it, the cactus, which I enable this, if I enable this, the cactus will receive that call to on trigger enter 2D, and then it will trigger the destroy. And you can see that catouch is being logged. So I know like this kind of, if you see this kind of bug, it may be quite scary because like how I know this, how I know, oh, kinematic cannot. I think one part is experience, then the other part is to just keep trying. Like for me, what I do is like I guess what's the problem, then I isolate it like an experiment and see whether it's correct. If I cannot do it, I check the forums, I check the Unity documentation, and that's how I normally debug these kind of problems. So now we have a somewhat functioning game, right? I mean, okay, hang on, yeah. I'm not very good, but so it's not being rendered. Have to set spawner to Z to 0. So this may not look very convincing yet. There are many things that need to happen for it to look like it's actually moving from left to right. One of which is we will not cover today, but we need the ground to move as the game progresses. But in our version 4, we do cover it. If we have time, we'll go through it. Hey guys, welcome back. Hope you had a good lunch, and we'll be continuing development. And so, okay, let's just do a recap on what we have so far. We have a player that can jump around. We have cacti that spawn at a particular position. And we have a despawner that destroys the cactus. So if we look at our checklist from before, which is around at the very beginning, so our player controller is pretty much set. Our obstacle behavior is expected for now, and we have a spawner. So right now we have some moving parts, but I don't think we can consider a game right now. One reason is because the interactions between these parts have no meaning, have no important meaning to the game, right? And you won't even know it's a game because there's no feedback on, say, your progress, or you don't even know if you lost the game or you won the game. So normally this kind of game state and game logic will be handled in one component called the game manager. This is one of many ways to do it, of course, but in this workshop, we'll create a simple game manager that manages the game's logic. So running back to this. So what I've planned is that the game manager must do the following. When the player is hit by a cactus, the cactus must stop moving. This is to simulate when the cactus has stopped moving, it's simulating the dinosaur stop running, right? So when the dinosaur dies or gets hit, the cactus should stop moving. Likewise, the spawner should also stop spawning because imagine the cactus is stop moving, but it keeps spawning more and more cactus over time in the game over screen. And this will cause a buildup of the cactus on the right side of the screen. Even though it's not shown in the game, it will still spawn and cause the game to run slow over time. Additionally, our game manager must keep track of the time elapsed and the high score and manage the game difficulty. As for managing the game difficulty, we will not cover it in this workshop, but I believe if we go through the rest, we'll be able to see quite clearly how we can apply it. Okay, so let's do some hands-on here. So as a recap, we're going to create a new game manager component game object. Same thing, game object. I rename it game manager. I drag it out. In this case, I won't put the sprite. And I'll create a great game manager script, like so. So this gear, right? You can just ignore it. It's just a quirk. It's a quirk of Unity, but it's still a script. It's the same thing. It's just that for game managers, this naming, it will display this gear icon. So normally what I would do is I'll write out the code, then I'll explain again. So hang on. Okay, so the idea is that when the player gets hit, we stop the cacti from moving, but we do not have a reference to all the cacti speed. What we could do, if we bring it to the side, is that in our cactus obstacle, there's this speed value that we can change, but this is a member variable of the cactus. So meaning if I change the speed of one cactus obstacle, it only changed for that particular cactus. But other cactus that are spawned will be spawned with a speed of 10. If we think about this carefully, right, all the cactus should have the same speed regardless, right? Because the dinosaur speed is, if we're simulating that it's a desert with many cactus, they should all move in the same speed with respect to the dinosaur. So we could use something called like a static variable. I believe this is not foreign to you guys. And this now belongs to the class. So anytime I change this variable, it will apply to all of the cacti. And to prove it, I can just something like this. Okay. Oh, sorry. Hang on. Since it's I want to say that since it's a static float, you cannot see it in the inspector anymore. Yeah, my bad. But the idea still holds that the speed is shared among all the cacti. So now that we have this static float, we can also then reference this static float in the game manager easily. Like this, we can just do cactus obstacle. And since this now belongs to the class, we can just set the speed to 0. Another thing is we need to stop spawning the cactus when the game ends, right? So in the cactus spawner, this coroutine is showing that it will keep spawning no matter what. So let's create a boolean to determine when we should stop spawning, like this. We'll make it a public boolean. So if it should spawn, then we will continue this loop. Else we would it will not instantiate anything. It will just this coroutine will end, and we can access it through a public reference like this. cactus spawner. And like this. Okay, so there are many parts about this that may be a bit confusing. So let me show you in the inspector what is happening. So let's attach the game manager script to our game object first. So first things is let it compile, and once it's done, we add it in like that. And now this spawner field is empty, and we can drag our spawner game object in here, and the cactus spawner component will be put inside. So let me just draw a difference between this and the spawner. Here, this is a game object, so any game object can be put in here. This is the cactus spawner, one of the public references. But in Game Manager, it's specifically looking for cactus spawner. So it's specifically looking for a game object with the cactus spawner component. If I put anything else, it doesn't work. See, like this spawner doesn't have the cactus spawner component. The player doesn't have it, but the spawner has it. And that's why it works. And through this, we can immediately get the spawner component without using the get component syntax that I showed you before. Okay. Now that we have done this, we just need to call this function when the player gets hit. And we can do exactly the same thing of how we got the spawner we can get the game manager into the player controller the same way as how we got the spawner into the game manager by doing a public reference like this, game manager. Oh, my bad. Game GM like that. And when we hit, okay, this is supposed to be cactus, but for our thing it's okay. On player hit, like that. So when we do hit a cactus, or if we do hit a cactus, then we call the game manager's method, which would then stop all the cacti from moving, and we also set the spawner to stop spawning. So far, okay? Okay, doke. So let's see it in action. Okay. So let me play a bit first, like that. Okay, so far okay. It will spawn the next one, and if I get hit, oh, it doesn't work. Why? So, oh, I forgot to set my game manager, my bad. So here, I can just drag the same way the spawner is dragged to the game manager. I can drag the game manager to the player controller, and it should work. Sorry about the hiccup. So, oh, it should not work. What? Okay. Let's just try this. Definitely this is not the reason only, but oh, okay. I know the reason. So in the previous example, we and I even covered in the slides. In the previous example, we just set the speed at the beginning, right? And now we changed the speed, but the rigid body's velocity it's still using the old speed. That's why it's still moving. So in order to curb this, we need to update it every frame. We have to update the rigid body's velocity, and anytime we change it, it will update the velocity of the rigid body, if that makes sense. So let me just illustrate first by writing some code. So basically, we have to constantly be updating the speed of the cactus's rigid body. In the previous previously we only set it once, but now we have to set it every frame for the off chance that the game manager sets the speed when the game ends, right? So if we look at it again, and now we got the desired behavior, and this player just flies away. Okay. So let's fix this player flying away. One thing you could do to prevent him from moving in the X direction, which is the horizontal direction, is we could set the constraints in the rigid body. So I click my player, go to his rigid body, under constraints, freeze position, and I can freeze its X position. Additionally, if you want, you can freeze its Z rotation to prevent it from twisting and turning. And now, so when the canvas hits the dinosaur, it stops, and this is the desired end state that we want for our game over screen. Okay, let me just shift the spawner first. Okay. Okay, so if you think about it, our game is like this is like a good state for like a MVP, which is like a minimum viable product. The idea is that we can already see how the game runs and how it plans out. We can also edit the speed however we want to tweak whether the game is fun. Everything else after this is just feedback to the player. For example, displaying the game over screen. You as the designer, you don't have to care about that game over screen to test how fun your game is. However, if you want other people to play your game, definitely you need to add these UI elements and these form of feedback to the user to understand, to let them understand your game, right? You won't be, let's put it this way, you won't be next to someone when you're playing your game. So you need to have all the information available to them packaged in the game. So one way to do this is to use a user interface. And Unity comes along with a easy way to add user interfaces to your scenes. So instead of creating an empty game object, we can add a UI. And for this case, we'll add a text, right? Yeah, we'll add a text. So there are many things that pop up in this one motion. One, a canvas is created. Two, a text box is created. And an event system is created. So for our purposes, you could ignore the event system and focus only on the characters and the text. So the purpose of this text, I'm sorry I didn't tell you guys, but the purpose is for now is to display the time that has elapsed during your game. This is very important for many reasons, but the main reason is that the player needs to know how well he's doing over time, right? And the best way to do it is to show a score, or in our case, we show the time. And as he progresses through the game, the time will be a form of feedback of how well he's doing in the game. And this would potentially make the game more exciting for him as he sees his score increase. For our design, we will handle this updating of the UI in the game manager. And so you can follow how I set it up, where this canvas is here, and I bring the text to the top right-hand corner of the canvas. Okay, as a quick explanation of this canvas, you can think of it as like, this is will be on your screen, and like this white outline is like the boundary of your screen, and you can put the text at specific locations, and you can anchor them over here. I will not cover through this, but just let you know, you can figure out how to anchor the text so that when the screen size changes, it will be more appropriately positioned. But for our tutorial, We'll just manually move it to the top right hand corner, and this will be fine for now. Next, we need to be able to update the UI with the time that has passed so far. Before we even update the UI, we need to keep track of the time being, keep track of the current time. And we can do this in the game manager like so. Every frame we need to update, say, every frame we need to update like a time variable. We'll store time as a float for now. And like I said, every frame, which is update. So update is called every frame. We update this time variable to the current time. So there are a few ways to do it. One way is you could set time equals time dot time, I think. Oops, sorry. So basically you're setting the time to the current time, but I also want to show you something that's very important where you can set it to time.delta time. Oops, sorry. So this delta time is probably one of the most important things you need to know. Delta time is the time that has passed between each update call. And with this information, you can do a lot of things, not just updating time. You could do things like translating objects with a certain velocity, and using the delta time, you can scale it according to your frame rate. Okay, that one, if we have time, we can elaborate further. But just remember that delta time is the time that has passed between each frame, and so every time update is called, I'm adding the delta time, and if the time is 0 and I keep adding the delta time over time, it will eventually represent what is the time that has passed since the start of the game. Okay, I hope that wasn't too much. All right, so now we have the elapsed time. Now we need to display on the screen, and we are able to edit the text that I just placed on just now using, again, a public reference like public text, like that. But this text should not, it's not in this namespace. Basically just do this Unity engine.ui. So you could think of it as like an importing system, and then you're importing the UI's text. And all we have to do now is every frame we update the time, the text dot text. Okay, let's rename it to something better. This text will be the time text. And every frame we do update the time, and the time text would be the time dot toString. So far, okay? So let's just do a quick recap. With a time value that records the time that's elapsed since the beginning of the game. And every frame, we update the text that's displayed so that the user will have feedback that he's doing well in the game. And lastly, most importantly, we need to stop the time. If not, after the player dies, his score keeps increasing and he's happy forever. We need to end his happiness. So what we need to do is we need to set a boolean like has game ended, and it's false. And we only update this time if the game has ended. So if the game has not ended, so sorry, like this. Oh, if the game has ended, then we don't execute what's below, and we know that the game has ended when the player has been hit. Okay, so let's see if there are any bugs, because there may be bugs always. Okay, let me win one more time. Okay, so we know we can spawn twice, and then Oh, I realized the new text is not updating because I forgot to drag it in here. My bad. Oops. Sorry. If I'm not wrong, you can't. Oh, yeah, you need to do that. Okay. So we drag the text from the hierarchy into this time text, and now it should be updating. So you can see that, yeah, when he gets hit, the time stops, and we're happy. I mean, we're happy with this 1.7 second score. So, yep. So there are many ways you can use UIs, and displaying score is one of them. There are many other things like buttons you could use for a menu system, and text box for user input. You could explore this and find it out on the documentation. The next thing we need to do, we can do is do a high score system. So the importance of a high score is something like one thing is you give the player incentive to continue playing, to beat his next high score. That's very important to make your games, say, more enjoyable, because beating a high score is something that you like people to. It's something that's very enjoyable for most people, and one key thing about this high score is it has to be persistent between games. So a naive way of implementing a high score would be, say, in the game manager, I set like let's say like this: game manager, float, high score, and then if the high score is if the time now is better than my high score, then it's okay. Then I update the high score, things like that. Excuse me. So this is very problematic because once the player turns off the game, this high score is no longer safe. It's, all of this game state is in memory and it's not actually written to a file that can be stored past the lifetime of this game. So we need a way to be able to have data persist between multiple runs of this application. And there are many ways you could do this. I mentioned in the slides. There are a few ways to do this. You could use player prefs, which I'm covering, scriptable objects, or writing to a file. So I won't cover the last two, but not to worry. There are tutorials from Unity themselves, and you can go and see how to do it. For player prefs, it's quite easy to implement, and for our cases, it's good enough. Right. So let me just set it up. So okay. So in order to use player prefs, you could think of it as like a dictionary where you ask for a key and a value will be returned. If the key does not exist, then you can return a default value. So for example, player prefs dot get float and say best best time, and the default value will be 0. So in your head, what you should be thinking is that you're trying to grab something from a dictionary. If it doesn't exist, we'll return the default value 0. So this makes sense for our best time. If the player did not have a high score, the high score will be 0. And if he did have the high score, it will return the correct value. So this best time is our high score. Next, we check whether the current time is better than the best time that we have, which is like this: if time is greater, because longer time means a better score, is greater than this value, then we can set like this. We can set the float to our current time. Okay, and likewise, we want to be able to display the high score on the screen. So we can repeat this process of creating a text here, copying it, dragging it down. So this text will be called current time, and this one will be best time, I guess. Okay, let me flip it around there. And now the game manager can get a reference to the best time text and update it accordingly, like so. Best time text dot text equals time dot toString. So only when you beat your high score do you update the best time text. And yep, it's enough. Additionally, we want to set the previous best time at the beginning of the game. So like this. At the start of the game, we can set our best time to whatever we have stored in our dictionary. So if there's a best time, we'll update it, and if it's not, we will set a 0 timing. So let's put this into practice and see if there are any bugs. So, oh, forgot to drag again, like this. So, okay, how come it's 40? I think it's from our previous game, like from our other projects. That's why it's 40. So let's see if we can beat 40 seconds. Actually, the best way is, okay, this is too long. Let me just set it. So it's 0 at the beginning, and I'm doing well, and then, oh, okay, I did well there also. Okay, I don't touch it. Oop. Yep, so our best timing is 11.75 seconds, and let's remove this to prevent overwriting our high score. And now it should work. It should be that in our player preference dictionary, the 11 point whatever seconds is stored, and when we run the game now, it will show that it's 11 seconds best timing. Like so. So imagine if we use the float example that I gave, it will just give a 0 value because the game will initialize the float to 0. This is very important for, like I mentioned, multiple runs of the game. So with this knowledge, we have now moved on to a new exercise, which is, oops, sorry. Okay. So currently our high score is updated only when we lose. Let's modify the code so that the high score and text is updated while the player is still alive. So for example, once my current time is greater than my high score will be updated over time. Did that make sense? So let me show you the difference. So if you observe, like in 11 seconds, once my current time exceeds my high score, it does not update. Like right now. So I want you all to try to update the best timing to the current high score, which is the current time. Was that clear? Oh, no, don't look at that. Maybe we'll put like 10 minutes or so. But this should be quite simple. Oh. Is it full coma?
Maybe.
It is.
Is there a non-scripting way?
Which one?
Is there a non-scripting way to make UI elements cover the whole canvas?
Cover the whole canvas.
Yes.
Example.
Like if I'm on 1080,
Oh yeah.
the size of my say sprite will be different from
Oh, the sprite.
no, UI element.
Oh, okay.
Oh, okay.
I think if you anchor it and you set it correctly, it should scale accordingly.
No, it's like oh yes, anchoring. Yes.
Right. Yes, Harold.
You want to? Oh my god. Okay.
My stuff for homework.
Oh, it works?
Yeah.
Yeah, I know. This
No.
Wow. So what happened?
I have no idea.
Scaling.
But you install anyway.
It is like no idea. I went to install the solution.
Oh, okay.
Delete that is like I go use my identity and I got the switch. So like it's all re-implemented. I don't know if that was probably the
That's good to know. So next time if I have that, I'll just try it. That's good. It's cool. Hey, you changed that to the dinosaur. But no anymore. Yeah. Oh, the like. Do you have to adjust it oh no, spread that edit. You can drag it. Is it?
Yes.
Be cool. Yeah. So did you say how much? So we go back to oh, it doesn't have a reference to begin. That's a box of the track begin. Track at the beginning. Yeah. Are you calling the individual you need to call it's really
control later. So like we say like so this yeah. The last one, like the little one. So, yeah, you just discuss also like the no, it's like this, but it's like double. Actually, I don't look like because I was speaking like roller coaster. You check the yeah, just joke. You want to yeah. So either stay off. So the jump was it's like you have to like so the idea is the game manager update the speed to like this setting of the so let's say the speed was 10%, but then the characters will have speed 10 throughout the whole game, even though he changes the speed. So every frame is changed. So okay, the flow is the characters speed, and at the start he set his speed to move to the left 5, but then the game manager says like the player got hit, then the game manager must update the character speed, which is this value, but the velocity of the rigid body will still not change. Yeah. So then it's like if I don't then it will not change because this is only caught at the beginning of the characters. So then but the one is all jumping. So it's like there's no like yeah, so then now when I set to 0 it will update. This is like you can just like implement it in the yeah. I thought oh, so just now I mentioned so young player they have similar challenges, but then like the nature of then you freeze the X means that you cannot but you can still jump is 1. So if you freeze the Y, which we can the obstacles are mainly no one like is both. Obstacles is like but when it comes to like maneuvering then you're picking obstacles because the collecting the collectible. No, the context of our game is not I don't think no, you know what? Because our idea is like we have to collect a list of stuff. So like it's better. Should I repeat the first one? Yeah, that's okay. Yeah. Of the game, you can check. That's what you do. Is there what do you mean? Oh, you're talking about this, right? Oh, it should be set. You can set it in the game window. Resolution. The video is just setting for details, but in the inspector there will be like so per unit and all the function. To have pixel perfect games is very hard. That's a plugin and shit, but that's very hard. It's very hard to play. So that's why our game is technically not pixel perfect, because if you notice, right, the characters, the pixel next to the pixels between each other are kind of blurred. It's to prevent like this artifact where since the pixel of the characters doesn't match directly to a pixel on the game, it will stretch. It will type pressure, but the idea is it will cause when the character is moving, it will start rippling. Do you see it?
I'm not using
We change the it will elongate and then shrink. So it's not pixel perfect. Yeah.
Wait, this is as close as pixel perfect I can get.
Which one?
This, oh gosh.
You need to care about your
Orthographic size.
Yeah,
After that, a lot of
CPU
things.
and
A lot of
yeah,
things.
not for me. But yeah, if you set the filtering mode for the pixel art to be point center, it will. It looks very bad.
Yeah, you need to say this is a preset and I put it in like some.
Someone made
Oh no, the pixel perfect camera. It's nice and all, but when you rotate some things, right, it looks wonky.
that's like aliasing.
I think it does aliasing also. That's why.
I guess following along. Yeah, that's just
Unicorn meta.
Because the game is going to use that engine is like 3D, then 2D is just camera on screen. Yeah. I don't like this.
We need an edit 3. Let me see what's next. How are they doing? Okay. Because we don't have time. I think. Yeah, we need to speed through like crazy. Okay. Oh no, everyone's stuck. They died at the text. Yeah.
Technically, we can do it the not so nice way of like current time as an attack or current time game object or time object.
Oh yeah.
It's easier.
I thought this is the best way to for them to just visually drag and drop. But it's okay. Shit, I'm running out of bed, so
I think there's 2 laptops here.
okay, never mind.
No, that's great.
Okay, guys, I'll be starting again in 2 minutes.
There's only one table, right?
Hello. I'm starting in. Okay, guys. Where we were walking around, so we saw that some of you a bit behind, but not to worry. The final project files is in version 3, which is like the ideal end state of this workshop. So you can always go back and check it out. Or if you want to catch up, you can just drag it from the version 3 files in the over here. Like over here, you can check the updated scripts here. And I think we are close to the part where we don't need to do scripts, but so I think I'll just go through from the slides. So one way we could do this is in your update, we do a get float for the best time, and we set the float if it's better than the best time. Something like this. So every frame we have to get the float from the dictionary. Then we set the float, and this works. You'll get the results you want, but you have to take note that these are okay. The arrows are not very accurate, but the expensive operations are these two: getting the float and setting the float, because you're actually writing to a file or something that's persistent. If you look at the Unity profiler, okay, never mind. We look at this. The better solution would be at the start we store the high score in some variable, and if the time is better than the best time value, we update it. We update the text based on the new based on the current time. The downside is that we don't actually update the player prefs in the update, but visually the player can see his high score being updated. So this is like a compromise that we have to make for a more efficient game. One thing that is also to note is that if the game suddenly turns off when you're playing, it suddenly turns off and your high score is shown to be recorded. If it turns off, it will not call the method when the player dies, and then it will not update the player preference, if that makes sense. Okay, just to repeat again. Visually, the player is seeing that his high score is updating on the screen. However, if the game closes halfway through his game, his high score is not saved. So this is one of the compromises we have to make when we try to optimize for the game. So there's no one easy solution. Oh yes. Okay. So one thing that we could do is we do on application exit. There's this function. So when the application ends, we could update the float in our player prefs. That one we can check discuss further. But here's an example of what issues we had. So this is actually from the Unity profiler. On the top part is the naive solution that I mentioned just now, and the bottom part is the more optimized version that I have proposed. If you notice here, the game manager update is taking 0.33 milliseconds. It may not sound a lot, but it's running every frame, so it's quite costly. And we can get the same effect if we store the variable in like a member variable of the class. So, and if you see here, you can see that the get float and the setting of the float is taking much of the time. So we must try to minimize such expensive operations every frame, especially in update, which is every frame. If you'd like to know more, you can check out the documentation. And to access the profiler in Unity, you could do something like under Window, General. Sorry, not General. Analysis, yeah. Profiler. And when you'll start recording. You'll start recording what's happening, and if you pause, you can zoom in and say like various portions to see what is the costly operations. Yeah, but we won't go through this too deeply. Okay. For this part, I don't expect you guys to follow along in the project, right? Because I would say this is a bit more complicated. I advise you to go back and when you're doing it on your own, you can refer to these slides. But right now, I'll just run through this. So for the animator, the Unity uses something called like a state machine. Are you guys aware what that is? So to put it simply, it's let me see if I can show you something like this. So these portions are various states that the dinosaur can be in for its animation. So let's run the version 3 here. So in this state, the dinosaur should be in the running state. Okay. So you see it's in the running state. If I jump, it goes to the jumping state. And if I'm good at this with multitasking, okay, this is the dino dev. So basically, between these states, you can only transit. Technically, you can transit between all the states. So from the running, you can transit to a jump state, and from jump, you can transit to a running state. But once you transit into a death state, you can't get out because you're dead, right? So that's one important thing to note. And let's go through how we can set it up. I need in my laptop, right? So let's go back to the V1 scene first. Oh. Okay, the first thing we need to do is to create something called an animation controller, which is something like this, which is this state machine. Oh, you help me turn on your computer. That's my computer. Thank you. So we can do this by doing create here, and we create animation controller, and I will call it Dino AC. Okay. And in your player, you can create something called an animator. And over here, this we can drag the controller into the animator. So essentially, you are bringing this state machine into the animator, and this state machine currently has no states or animation states. So the idea is we put in animation clips or the states into this state machine, and depending on our current game logic, we will transit between these states to play different animations. So let's begin by creating an animation. So previously we have already sliced a sprite sheet. So just as a backtrack on this, the sprite sheet would come something like this, where there are many little sprites of showing different frames of this character. And the thing that we did for you beforehand was we went to the Unity sprite editor and we did some slicing for you so that they can be cut into different frames. You can learn more from the documentation on the sprite editor. I think I've linked it somewhere in the slides. So now we want to create a new animation for this animator controller. The key thing is we have to click the player. Okay, this is kind of funky, but you have to click the player, then we click the animation, then we can create the clip. So sometimes you won't see this, like for example, like to begin creating for spawner and stuff and create an animator, you have basically just click the player first. Then you can create the animation clip, and we can put it here. So the first animation I want to do is running. So okay, I call it running, anim, and we choose the correct sprites we want to use for its running animation, which is 1, 2, 3, 4. This from here to here. So these 6 guys can be dragged on like this, and you have 6 frames. And if we play, look, oh, so cute, but he's running too quickly. So one thing we could do is we can lower the samples, or we could drag this out further. Oh, my bad. We could like manually drag it, which is did I mess up something? Oh, the rectangle. Oh yes. So, but another thing you could do is just reduce the number of samples, and when you sorry, my bad. So now you can see that he's trotting away, as they call it. So find a good sample rate. I think what was advised is 12 rate. All right. Okay, so we have created one animation, and actually, since we have attached the animation, the controller to this to our player, if we run, he will be constantly in the running state. Okay, no, yeah. So even though he has been hit and he's been injured, he still can run, which is not ideal. So we okay, let's make the jumping state as well. So we could do the same thing where we try to create an animation in the animation window. So the same thing, click the player, click the animation window. If you cannot find it, you can find it under the animation here. And now there's no create new clip, right? You need to click here to create the new clip. And oh, wrong place. Okay. Jumping. I call it jumping. The example how many take. Okay. I'll just take the it looks like these 3, right? Am I right? Just one. Okay. We just drag this one guy here, and if we click play, he'll be permanently in this position. And notice how the state appears in this animator window. And we can now make a transition to this. And if we click play, right? So okay, we need to find a way to prevent this running state from going to the jumping state, and only move it to the jumping state when we want it to, which is when we press jump. So for this transition, one thing we could do is create a parameter over here. If you look on the left, my cursor, we click plus, and for our example, we use a boolean, and we call it jumping. And now we can add this to be true. So only when jumping is true will I transit into the jumping state. So okay, hang on. Okay, see, okay, do you all see that? Okay, let me repeat. So look, okay, never mind. If I click the jump here, the jumping boolean here to true, I'll transit into the jump state, and this is the mechanism we'll use to transit into the jumping animation. And of course, from jumping, we must be able to transit back. And for this transition, this upward arrow here, set jumping to false. And then all we have to do is we jumping, then we stop jumping, and then we go to running, jumping, stop running. Okay, so now we know there's this option available, but definitely we can't click on this button in the game. We have to somehow we have to use a script to manually edit it. So this can be done in the player controller script. So if we click here, we open. First thing we need to do is get a reference to the animator. So I call this anim, and there are many ways you could do it, but for this one, I can just get it directly from the game object like that. And when he's jumping, when the player can jump, I can do anim.setBool, which is I can set the boolean. And what boolean am I setting? It's the jumping boolean, and I set it to true. And of course, if the position is, if he's grounded, which is this variable we set, we will set him to jumping to be false. So we could do a check before here. Okay, and I hope this works. We will check it out. So we are running, I hope. Running, jump. Running. Okay, so there's one thing that you should take note. If you stare at this guy for long enough, he's still running, right? Even though he's in the air. So it means that he needs to finish all his animation frames for the running state before he can transit into the jumping state, jumping animation, which is that one sprite. So over here, we can toggle this exit time to be off. And in general, I like to turn it off for things that I want to instantly transit into. So now if we look, you will immediately go into the jumping animation like that. And the moment he falls, you will start running again. Okay, that was great, but it looks cool as well. Yeah, that's a feature. So I think this brings us to another exercise, right? Oops. So we have done this. We have created the states, setting the animation. Oh, this. I think it's fine. Okay, so we got a new exercise. If you would like to try it out, basically from the jumping state. Now we're done with the jumping state. We need to finish off with the death state. So we need to figure out. We need to just basically update the animator to play a death animation. So if you guys have reached this far, we can. Feel free to try this for 15 minutes. If you guys are still struggling, I will be walking around to help you all. Right?
Animation. Zero point 1, 0.2, 0.11, 1.0.
Yeah. You think there anyone's doing the? If not, I just finish it out. Anyone doing this exercise? If not, I'll just run through it quickly. No, okay. No worries. It'll be edited out, and then. So basically, we can just do the same thing, right? All we got to do is create a new animation like this. Click player, click animation, create new clip, def, find the correct sprites like this. So for our cases, we only use one of these. Normally this is for, let's say he's hurt, right? Okay, let me just show you what this is for, because it may not be very obvious. So if you look at this, if he gets hit, then he like flashes. That's the purpose of this, but we will just discard the other two. So we just use one. And so this is his death animation. And it appears in the controller. And all we have to do is make two transitions from here to the death. And we just create, say, we could use a trigger. So I'll just introduce this to you all. A trigger is like something like when you trigger it, it will execute this transition if you are in the correct state. So for example, let's say I create a new state here, say random state. And from running, I went to random and I click a trigger death, but there's no exit state from random, so nothing will happen. However, if that state that you're in has a transition with a trigger, then it will execute that transition. So example, death is a trigger, and for these two, likewise the Boolean also applies. As long as you're in the correct state, then and you have the correct transition, it will do the transition. But basically, running or jumping, if I'm running or jumping, I can just trigger the death, Okay, I misclicked. Sorry. Wait. Oh, it died. Okay. Yeah. So yeah, so when I click the trigger, right when I set the trigger, then it will transit into death. And for the instant death, I need the exit time to be removed. So if you saw this transition, I removed the exit time here, and I removed the exit time here. So there will be an instant jump to the death animation. And programmatically, we need to do something about it. So over here, this is basically when the player gets hit. So all we have to do is animator.set, my bad, anim.set trigger. And then we just put the name, which is death. So it's a very apt name. And if everything goes correctly, let's make this. Running, jump, running, and death. Okay. So there was we also need to check for the other case where he's jumping and then he goes splat, right? So if I'm very good, I should be able to do this. Okay, hang on. I have to jump earlier. Earlier, right? Okay, so that's a bit funky. We have to always adjust the hitbox, but yep. So basically, we have detected death and we have played the death animation, and he's deaf. So okay. I moved it around. That's what happened. So if I trigger, he should die. Okay. So let's see what's next. So now what? We now have our basic gameplay elements. So, but surely we could do more. For example, as I mentioned in the previous, at the beginning, we could do main menu, game settings. Something that is very important is that we didn't cover is sound, like sound effects. Yeah, sound effects such as like a jumping sound like poop and deaf sound. We could do more obstacles. For example, okay, I don't know who suggested flying pterodactyls, but yeah, we could have something like, land before time, and then the meteors are coming, he needs to run, something like that. I don't know if they were cactus then, but something like this. And other creative twists. For example, maybe a power up, then everything goes trippy, and then he can clip through cactus, he can eat the cactus can eat him, something like that. There are many things you can explore. And to know whether it's fun, we need to play tests. So this is the version 4 that we kind of created, and there are many small details that I'd like to point out that are not very trivial to implement. First thing is there are two scenes for this. The first scene, okay, let me go here. In version 4, there are two scenes. One is the main menu scene. So we have like dinosaur looking into the distance, and then Dino Runner play quit. I don't think quit does anything at the moment, does it? In the editor, but so when I click play, so this is the menu, and then look, you can click play, which then loads the other scene. So observe this part, like where my cursor is. And then now you load this scene instead. So it's, oh yeah, there's sound effects. Okay, let me play it, then it's better, right? Okay, so let me talk to you while I try to beat my high score. If I hold, it's okay, right? Okay, so we have jumping, we have cactus. Another very important thing we have is the parallax background. If you notice, right, the front element of this, the front hill is moving slower than the back hill, and the clouds is moving slower. And notice the ground is also moving at the same rate as the cactus. And if I did it correctly, if I increase the speed, it should increase accordingly. So definitely we could have improved this. We could have done additional stuff like we could put additional stuff like spawning different obstacles. We could do stuff like increasing the difficulty. There's so many things we could have done with this, but we just want to just show you something there's a lot more things you could do, and perhaps this could be a good way to learn what we did and then implement your new features. And then going back to main menu. Say this is cool. Right. Yeah, and let's see. So let's go back to the very beginning where we started this whole thing, where we're talking about the considerations. At the very beginning, it kind of didn't make sense because you don't really know what you can do with Unity. But now you guys know, you're not clueless, right? I hope. You guys at least know the very basics. And now you can think about how what kind of game you want to make. As you can see, game development can be fun, but it's also very tedious and a bit tiring. So always remember, the first thing you do is when you decide what kind of game you want to do is but first definitely think of a game that's fun, but then second, and also very importantly, make sure that you can finish it within 3 months for Orbital. That's like one of the most important things. You do not want to have like, oh, I want to make the next, say, I don't know what, Candy Crush. That's okay. Say like the next RPG, that World of Warcraft or whatever. Because definitely you can't do it in 3 months, right? There's no way. But well, you could. No, you couldn't. No way. So always, perhaps you can look into World of Warcraft, right? And you say, what part of World of Warcraft do I like? Then you scope in on a mini aspect of that game, and just create a game around it, and try. And since it's a small feature of that a big game, perhaps it'll be fun, and it's something that you could explore. So also start simple. Even though I said start with a small feature, a small game, you still can break it up into even smaller parts. For example, our Dino game, we had part 1, we had part 2, part 3, version 4. So think about like your milestones, right? In Orbital, if I'm not wrong, you have some like 3 milestones. So in your first milestone, has it passed already? No, haven't yet. Okay, so maybe you try to work to a prototype, a working prototype. For example, like our version 1. Work towards that for your first milestone. Build the game and let people playtest in your milestone. And you don't have to be restricted by the milestones as well. You could always just build the game, share with your friends, share with whoever you know, and ask for their feedback. Because the most important is feedback for a game. You don't want to go in blind, like 3 months, you work very hard, and then you realize that people don't find it fun. So iteration is key, and using the milestones is a good way to pace yourself and make a good game. There are other things that you may want to take into account. It's like a version control. So I believe the Liftoff had a Git workshop. So it's not very different, just that there are some pointers that I'd like you all to take note if you're using version control. One thing is when you're working in pairs or in a team and you're working on a feature, try to work on different scenes. So let me illustrate. So for example, say my friend Stanley is working on the main menu and Harold is working on some gameplay feature. You create 2 scenes, and then each of you only touch your own scenes. And then when you do a merge, it'll be a lot cleaner. Imagine, let's say, Stanley is doing game manager, then Harold is doing jumping. And we all both edit this Unity file. It's actually a .unity file. And once one guy merges in, the other guy will have a merge conflict, right? And in order to resolve that, it's like you have to look through the meta files and all that nonsense, which I think it's best to avoid. So when you're working on features concurrently, work in different scenes. There are many other tips over here on this side, but I would like the scenes thing is quite important. There are also many helpful resources. There are some general Unity guides. I really like these two YouTubers. And yeah, most of the links I have are YouTubers because I think the videos are the best way to learn. If you're interested in Unreal Engine, these are some of them that I have referred to before. and just general resources. And most importantly, it's like assets. We need to find free assets because not many of us are good at game art, and game art can be a challenge for us. Some of us choose to just use squares and circles. But let's can we go? Can we click this? Okay. So this should be safe. And so over here there are many free. Some needs to be paid, but you can find like assets. And you can find a lot of these stuff. I think some are free. Like I think if it says download, if it says donate and Patreon, probably it's free. And yeah, if you're gonna support him, please donate. But the whole point is that it's free for us as students. And also, I see that the Slack is not really populated. Like I think there are more staff than students in the game dev Slack. So if you want, just join, and it's also a good way to post your game. So after you build your game, you can just maybe send a Dropbox link or a Drive link, let people try and ask for feedback. So having like a small community to approach for this kind of feedback is very important. So if you don't have that, there's NUS Games Development Group. You can join our Discord at this link, or our Facebook is over there. If you do not already know, I'm from the NUS Game Development Group, and we have weekly sessions during the semester where we try to teach stuff like Unity or work on games together. And at the end of this year, there's this game jam, a 24-hour game jam where you form small groups to create a game in 24 hours. So there'll be more announcements made on our Discord and our Facebook, so do look out for that if you're interested. And that's it. Thank you for coming. So I think I was talking to someone about the stretching thing. I can show it to you. So so I think this is the talk has ended, but I'm just sharing some stuff that I was talking to other people about. So they are like asking about I think the conversation led to some talk about pixel perfect games, and if we do point filtering and we look at the characters. Oh, I have to apply? Yeah. Okay, it's not very obvious, right? Okay, wait. Let me remove the player first.
Compare the difference between the two modes.
I think it's quite obvious. We try first. Oh yeah, this is not compulsory or whatever. Is this workshop even compulsory? No, right? But thanks for coming, guys. I really appreciate it. So it's too fast, huh?
You can pause the.
Oh, right. It's not very obvious. Let's slow it down. Wait, does that work? Have to restart? Oh, right. You really know nothing. I'm just sharing stuff. Okay, can you see it like flickering like crazy? And if you look even closer, it's actually stretching. So is it okay if I use Stack Overflow? Okay. Yeah. I don't know how your browser later feeling right. No, what's it called? Is it? Wait, it's stretching. Oh no, there was a very, very specific thing that had an animation I showed you, right? Yeah. Remember? I forgot what it's called. Oh, okay. Yeah.
But if anything you all want to discuss, go outside.
Oh yeah, if you all want to talk for like consultation with, say, Stanley or Harold or I, just feel free to approach us now while I search for this to prove my point. Is it flickering? No, I think sprite stretching. Waving.
It's not sprite DB, right?
No. Okay, found it. Okay, this is what I'm explaining. So if you notice, right, cause the texels are like it's not mapped 1-to-1. So basically, if I'm not wrong, the sprites, this mushroom is more than 17 pixels, but it's trying to map it. Wait, let me see. So the sprite is 16 by 16 pixels, but it's occupying 17 by 17 pixels on the display. So you get this stretching effect. Because once it crosses a boundary, at some point, it will do like a double count in a sense. And this is what happens. So ideally, it should be perfect, or 2:1, 3:1, so that you don't get this nonsense. You get this. Yep.